Hey, welcome all on Vedantu. I am Jimmy Ahuja. I have been teaching mathematics on Vedantu for the past 4 years, and I have been teaching this Sprint X second series in which we are solving previous year CBSE board paper of 2018. We have already taken 4 sessions and we are covered 24 questions so far. This session will start from question number 25, which are 4 marks question. Okay, and I hope if you have not watched those videos, you will watch them first before watching this. You should watch it because that's very necessary. Next is the schedule. You should note down. This is the 6 p.m. and 8 p.m. classes. This is the 6 p.m. class that we are going right now, and this is 13th February class. Okay, I hope you have noted down that timetable so that you do not miss any class. And regarding that, one more thing, the Vedantu app you should have downloaded because it can help you in doubt solving. It can provide you all the study material you need. Moreover, the classroom is there where you can watch the videos just through that app. You don't need anything else. Yeah, that's cool. Yeah, so let's take up the problem number question number 25 and try to understand how we can solve it. So the question says, in an equilateral triangle ABC, D is a point on the side BC such that BD is equals to 1 by 3 BC. Prove that 9AD square is equals to 7AB square. Now in this question, what we are going to do is, we are going to frame equations based on what? Similarity or Pythagoras? See, when you see an algebraic equation, power squared, I'm telling you, you will apply Pythagoras, you will get the answers. Don't use similarity in that. But when you get ratios equation, multiplying equations, then you apply similarity. So, but when you get algebraic 9, 7 plus 3 times something, then you use Pythagoras. Okay. So in this question, first of all, we need an equilateral triangle. I'm going to make an equilateral triangle for us so that we can continue with it easily. Okay, so consider that this is an equilateral triangle, and in this equilateral triangle we have A point, B point and C point. Fine. So consider that we have got the sides. We should mark some sides, but they have given a point D which is on BC. So which BD is 1 by 3 BC. So take D here. It is 1 by 3 of BC. Remember this thing. And now you are going to drop a perpendicular from A because I cannot see any perpendicular like Pythagoras. How can I apply? I cannot apply Pythagoras without having a right angle triangle. Yes. So what I say is the thing. I name it as E. Can I now say that BE is half of BC? It should be, because you know E is the midpoint also. It is the median also because it is an equilateral triangle. So BE is half of BC. And what is what I say? AE I do not know, but I know this is an equilateral triangle. So in that situation I can just say this thing. Let us take this is what I take, x or 2x. I take x. I have taken BE as x, so this means this is also x, correct? So what will be AB? 2x, because because it is equilateral triangle. So BC, AB and AC all are equal. Now in that situation, let us find the side AE first. But before that, I want to tell you why I am doing it. Otherwise, what will be the use? Just focus that this half side is not important because it is same as this, because this is an equilateral triangle. What is important is AD. I want AD. And what is important is AB. I want AB. Fine. But how many right angle triangles do you see? You see, don't say 3. I also see 3, but right now not. 2. ABE and ADE. So I am going to apply Pythagoras theorem for triangle ABE. What shall I get? Tell me, what should I get? I will get AB square is equals to AE square plus BE square. I'll write like this only right now. Try to understand. I'll change everything. Just wait. In triangle ADE, what will I get by Pythagoras theorem? AD square is equals to what? AD square is equals to AE square plus DE square. Now tell me one thing. Tell me right now, do you think I need AE? No, the question has given us the solution, you know. It has already given you the solution. Just keep doing what it is asking you. You do not want AE? Subtract these 2 equations. What shall we get? AB square minus AD square is equals to, this is cancelled, BE square minus DE square. Now try to understand. I want AB and AD only. I have got AB and AD. I do not want this. I'm going to get rid of this. How? Let's check. What is BE? BE is BC by 2. It is x for us. Just take x. Just take x, it will solve. Trust me. What is DE? So DE I do not know. I do not know DE. Yeah? But do you understand that what is BD? BD is 1 by 3 BC. What is BC right now? BC is 2x. So what is this? 2 by 3x. So what is BD? 2 by 3x. And what is BE? X. So can I find DE? Yes. What is DE? It is x minus 2 by 3x. Try to understand this point. And just appreciate this fact how easily you can convert it in terms of x. See, this is BE. This is BD. If I subtract this, then I'll get DE, which is I have done, which I gets to me x by 3 only. Now I got DE, I will write x by 3 whole square only. And just understand, I'm changing AB also in terms of x right now. I need to, I'll make it back to AB, just I need to. So what is AB? AB is 2x. So it is 4x square. I have a whole square it also, minus AD square. Now just simplify this, you will get x square minus x square by 9, and this will be 4x square minus AD square. So you bring all the terms of x square here, send AD square on the right hand. I'm going to add a page and I'm going to do it. 4x square minus x square plus x square by 9 is equals to AD square. Let us check whether we have written the correct thing. We should. That's important. So minus x square plus x square, and that's correct. Let's take the next part. So what we will have? 3x square plus x square by 9. Take the LCM 9. What we will get? So I will have 9 3 to 27 plus 1. 28x square equals to AD square. Are you done? Have you understood this? Now send this 9 there. Just send it. Don't worry. Trust me. It is easy, you know why? Because you are doing in x. Now what do you want? See, you want 9AD square. Have you got it? Yes. What they are asking you to find? 7AB square. They are saying what? 7. What they are saying, keep on doing that. Whatever they are saying, keep on doing that, you will get the answer. You want 7, so write 7 and write 4x square. Okay, now what is 4x square? AD square only. I just showed you in the last part. So it is 7AD square is equals to 9AD. Sorry, 7AB square, not AD. AB square. See, AB is 2x. What is AB? 2x. So its whole square is 4x square. You understand how we got it? Just in terms of x we have got it. Do not do anything extra. Do not take BD, BC, BE. It's too time consuming. It's too confusing also. Just try to understand in this way and you'll get the answer. You have proved it. Okay, let's move to the next question. Fine. This is a question they have asked in, okay, or. When they are asking a question in or, it means either you can do that or this one. That was a very easy question. I would have selected that if I would have given the choice. Let us try to understand this also. Prove that in a right triangle, the square on the hypotenuse is equals to the sum of the squares on the other two sides. They are asking us to prove Pythagoras theorem. In other words, you understand why? They are saying in a right angle triangle, prove that hypotenuse square is equals to the sum of the square of the other side. So to do that, you need similarity. And I'm going to not teach you similarity in detail because it's just a question solving class. But you need something to build upon. So I'll start with that. I'll teach you some basic things also, don't worry. Oh, I don't need that way. Okay, this is fine for me. I think so. I'll just adjust it a bit. Oh, that is good. I'll go with that. Just understand that this is what I've done is basically I've drawn a right angle triangle here. And I have written say B and this A and this C. So I need to prove that AC square is same as AB square plus BC square. Fine, this is what we want to do. It's a lengthy question, so just I will not select it. That's why I've said. Fine, this is Pythagoras theorem proof, but we are doing it. So for this you have to drop a perpendicular from B and mark it 90 degree. Now try to understand. I'm going to use similarity. So what I'm going to say is this. Just tell me, is this angle X? If I consider, what this angle be? 90 minus X. What this angle will be? 90 minus x, because this is 90, this is x. The sum should be 180. Correct? What this be? X. Why this will be x? Because this is 90 total. Correct? So this is x, this is 90 minus x. The sum should come 90. Now if this is x, this is 90. What is this angle? 90 minus x. Have you understood what I done? I considered that as x. I had found this is 90 minus x by sum of the what do you call? The angles of a triangle is 180. Then I found that this was 90 given to us. So I did 90 minus x plus x. That will become 90. And this is x. This is 90 again. So 90 minus x. Fine. Now can you see there are 3 triangles which I can prove similar kind of. I'll just do this. I'll prove the bigger triangle and the smaller triangle similar. Try to understand what I'm doing. I am proving triangle. Just go slow, okay? Triangle ABD. I'm going to vertex matching technique is called. That's why I said I have to teach you everything. So take the gist. It's vertex matching technique. I'm gonna use ABC triangle. So I need to match the correct vertex. The angle should be matched. So in ABD, what is angle A? Angle A is x. So in ABC, what is angle A? Angle A is x. So A is matched with angle A. That's done. Now in angle ABD, what is angle B? ABD, angle B is 90 minus x. What is 90 minus x in the bigger triangle? C. Absolutely correct. Now you understand how we do it. Okay. Now in ABC, you need ABD is D is 90. Angle D is 90. What is in ABC? B angle is 90. I hope you understand. I actually proved the similarity also by matching the vertex actually. Just appreciate this fact what I have done for you. So what we get? We get AB, angle ABD is equals to angle ACB, and angle BAD is equals to angle CAB. If you do not want to write the first one, I can save you from that also, no issues. Just write this one. Both are 90 now. Angle ADB is equals to angle ABC is equals to 90 degree. You just write, we have drawn BD as construction. Right? BD is perpendicular to AC by construction. Mention this so that the teacher doesn't cut your marks. And then do this, okay? So now you got it. BAD. What is BAD? So common you can write. Now since both the angles are same, 90, so we have therefore triangle ABD is similar to triangle ACB. Have you understood this? Triangle ABD is similar to triangle ACB. Now if these two are similar, I don't need to see the triangles. You know, this is what is vertex matching technique does for you. Just look at this naming. You have done it correct. 2 words of this. 2 words of this. First and last word of this. First and last of this. Sorry, second and last. Then first and last AD upon AB. Remember what you wanted to prove. What do you wanted to prove? That AB square plus BC square is AC square. This is the target. This is the Pythagoras theorem. If I take this and this, will I get AB square somehow? Yes. So I'm taking that. This implies AB square is equals to what? AC into AD. AC into AD. I'll keep it my equation 1. I need it. Fine. Have you got it? Okay. So AB square is equals to AC into AD. I do not know BD or BC right now. I'm not all interested. So since we have got it, I will I'll shuffle a lot. I'm going to prove the other smaller and the bigger. So I get BC also. Na? I want to get BC square also. Na? I do not get BC square from this place. So I'm going to use BCD and ABC. What I'm going to use? BCD and ABC. So I'm going to use triangle BCD and triangle. Now I have to search. Now keep a close look on the diagram. Please follow the diagram. BCD. Angle C in ABC also has the same angle. So C vertex is matched with C vertex. Okay. Fine, I should come here. Yeah, I've written here. So C vertex should match with C vertex. That's correct. C is matched with C. Let us check what is B matched with in ABC. What is BCDB? It's X. What is this? X. So now I want in the bigger triangle an angle which is named X. What is that angle? A. A is X. In a smaller B is X, in bigger A is X. So I've got A. So B is going to be matched with A. B is going to match to be A. Just write B because you were searching for this triangle only, ABC. But you wanted the correct vertex. Now you just have the fun. You have everything. Just write angle BDC is equals to angle ABC is equals to 90 degree. Both are 90. And then you can write that angle, whichever angle you prefer, since C is the common. So BCD is equals to what? Angle ACB common. Now since we have got this, do you all people say that triangle BCD is similar to triangle ACB? You should mention the axiom or the theorem. I forgot to write in that place. Just write it down. So now 2 letters of this upon 2 letters of this is equals to, I want okay, first and last and first and last. Okay, I want one more. So CD by AB. Fine. So first two CD, and it should be CB here, which I have written wrong. Okay, I saw it, CB, and first last letters. Now see, CB is same as BC. I wanted BC square, remember? So I will cross multiply. I'll get BC square is equals to AC into CD. Have you understood it? Yes, you should have. Yeah. What we got? BC square. What else we got? AB square. Now you have both of them. You just need to add them now. AB square plus BC square. That is what Pythagoras theorem tells us. What is AB square? Remember, AC into AD. What is AB square? Okay, I have to add it. Just a minute. It's fine. What is AB square? AC into AD. Correct. What is AB square? AC into AD. Come back and notice. What is BC square? AC into CD. Now you are getting it. You just are there. What is BC square? AC into CD. We have to add them now. That is the formula now. So we make it. So AB square plus BC square is equals to what? It is AC into AD plus AC into CD. I can take AC common. I will have AD plus CD. And what is AD plus CD? You see the diagram now. Then I'll let you know. What is AD plus CD? It's AC only. Yeah? It's AC now. So just take it AC. So it is AC into AC. Oh God, I have got it. I'm really happy now. I have found this. And you have been there for me. Yeah? You were listening to me. So I'm more happy now. Because I found it with you. So AB square plus BC square is equal to AC square, which is the required equation. Fine, we have done it. Great. I hope you have understood it. We did it through the similarity path. Let us take the next problem. Fine. Okay, this problem is a construction problem. It comes always in the 4 marks. They give one problem always, okay? They can ask you to make circle tangents, or they can ask you to make similar triangles. I'm just going to teach you the steps because obviously I can't make it compasses, okay? So in a triangle, draw a triangle ABC with that much sides. Angle BC is, B is given, 60 degree. So if B is given, I'll draw this B. I'm telling you the steps, just follow it please. B is 60, so make 60. What is BC length? 6 centimeter. Make it 6 centimeter. What is AB? 5. So take a compass here and put an arc somewhere. Okay? You get it? Put an arc somewhere. So it is 5 centimeter. Fine. Now you got A. This is the A point. You got it? Join it. You got the triangle actually. You got the triangle. Now what you want? You want to make a triangle whose sides are 3 by 4. It's going to be shrink down. I'm telling you the tricks now. Leave it. I will tell you the tricks now. First, draw an arc and always draw a ray, always 60 degree. Remember, you always make it 60 degree. Do not apply any brain and do not ask me why. Yeah, I'm teaching you to help you out. Always make 60 degree. Do not write 60 degree, but make 60 degree. Okay. Now, what is the 3 by 4? What is the highest value here? 3 or 4? Highest value 4. Put that arcs, equal arcs. Put your compass, put it out. Write B1, B2, B3, B4. Fine. Which value is greatest? 4. Put that value, b1, b2, b3, b4. Now, what is in the, what do you see? You want to shrink it. Just remember this, what I am telling you is the rule. What is the denominator value? 4. Always join the denominator value with the last point. Always join the denominator value with the last point. Do not ask me why. It's because I'm shrinking. It's a concept behind it. Just try to understand. You are going to solve this first. Denominator value, add it. Just join it. If it was 3, you should have done 3, the third one. Okay. Now you join it. Now whatever angle you are here. So just put your compass here. Draw an arc. Okay, I'll change the color. And now put your compass on this value, numerator value. What is numerator value? 3. Put the compass here, draw an arc. Now, put the needle of the compass at this point where your first arc has cut and measure this length. Put the pencil here. Now, keep the compass needle here and put the pencil here. And then, obviously it will not be there, kind of there. Okay, it will be here only. So now you have to join this. Wherever it cuts, it is your C dash. This point with the dash. This point with the dash. Okay. Fine. Now you copy this angle. So just do the same. Draw an arc. Come here. Draw an arc. Put the needle of the compass here. Measure this with the pencil. Put the needle here. Measure this with the pencil. Okay. Now join this. Just you have done. A is A dash. You got the triangle A dash B C dash. You have understood the steps? It was easy, correct? It was very easy, okay? You don't have to get confused in this. I've told you, you can rewatch the video to understand what I have said, okay? Oh, fine, sorry. Oh, I'm moving to what page? Okay, I'm fine at this. Fine, this is the last question for today. It's the question number 27. It's a trigonometric proof, a very easy trigonometric proof. They have asked for 4 numbers. Sometimes it happens because some questions are too much lengthy, so they put a smaller questions also, where you have to apply brain, so it can be shrink down. Okay, if you go by conventional method, it is too long. So the question was like this: sin A minus 2 sin cube A. I've written it for you. It was a little bit hazy here. 2 cos cube A minus cos A equals to tan A. Fine. First step is just see what is they have to prove. Tan A. So in direct it comes our mind, sir, if I have sin A by cos A, I will have tan A. So I will take out sin A common. Okay, I'll use the other color only. That's okay. So I take out sin A common. What will be left? What do you say? So 1 minus 2 sin square A by, what can I replace this? Cos A common. Oh, I got tan A. I'm getting happy now. So 2 cos square A minus 1. Remember an identity, sin square theta plus cos square theta is equals to 1. Either you can replace one place of sin square or this place, otherwise you have to replace 1 at both the places. Now which is more better? Replace either one of it, na? Why to replace 1 with sin square theta plus cos square theta? So I will use this identity that sin square theta can be written as 1 minus cos square theta, and I'll put it here. Or if you want to save your time, you want to literally save your time, do not put that. Put cos square 1. Now you know why I'm doing it? I saw it was minus and it was troublesome. It is plus here. I'll put that. I love plus signs. So cos square A is equals to 1 minus sin square A. See how easy it becomes now. Sin A by cos A is tan A. I have got the answer. I want to get rid of this. I just want to get rid of this. I'll get 1 minus 2 sin square A. No change in numerator. Put 2 cos square A, you write 1 minus sin square A. Minus 1. Now see what has happened. It will be 2. 1s are 2. 2 minus 1 is what? 1. And 2 into minus sin square A. So minus 2 sin square A. I hope you understood what I have done. 4 lines. And it's solved. Do you understand? What do you say? Do you understand? Yes, you should, huh? Why you don't understand at this point, huh? I'm so getting, it's getting good. Tan A only I wanted, I want that. And I kept it saved. I kept it saved. I just started thinking, how can I get rid of this? And I do not put sin square A because it was minus there. So that's why I selected cos now. And I put it and simplified it. I hope you have understood how easily you can solve a problem which can be tricky otherwise. and you have understood also how to apply the similarity method. That is very important. Okay, so now this is ending of the 5th session with 27 problem. The rest 3 problems, 28, 29 and 30, will be in our next session at 8 p.m. So do join that session also, and I hope you have enjoyed this session. If you have, please do like this video, share it with your friends, and do not forget to subscribe the channel, and do not forget to press the bell icon button. We'll meet you again. Thanks for being here. Bye.